Now, there is a very common question that why you need to balance these equations. Why is it so important to have equal number of atoms on both the sides? Why balance equations? The reason for this is that according to the law of conservation of mass, mass can neither be created nor be destroyed, and also atoms can also be neither be created nor destroyed. So if they cannot be created and they cannot be destroyed, then there should be no change in the number of atoms on the left hand side and the right hand side. The main thing is that atoms cannot be created and cannot be destroyed. So if they cannot be created, they cannot be extra atoms on the right hand side, because if there are extra atoms on the right hand side, it means that some atoms have been created. And they cannot be destroyed, so there cannot be lesser atoms on the right hand side, which will mean that the atoms are destroyed. So in this reaction, Mg plus O2 gives MgO. There are 2 atoms of oxygen in the left hand side and 1 atom of oxygen in the right hand side. So it means that one oxygen atom has been destroyed. But that cannot happen. That is why we need to balance this equation. So if you are asked, why do you need to balance the equations? You have to say that since atoms can neither be created nor be destroyed, you need to have equal number of atoms on both the side of the, both the sides, in the reactants as well as the products. So you need to balance the equations in order to make the number of atoms of each element equal on both sides. So the thing is how to balance the equations. Suppose we have this very basic equation. Mg plus O2 gives MgO. Now you will see that there are 2 atoms of oxygen on this side and 1 atom of oxygen on this side. So you need to make this 2. You can't make this 1 because there is only 1 molecule. You cannot make it half a molecule because they will always react in whole molecules. You cannot have half molecules reacting, or quarter molecules, or any fractional number of molecules reacting. So you cannot make this half, so you make this double. So you add a 2 over here. Now this 2, you cannot just make the number of oxygen 2 because this is a whole compound. If you have to have 2 molecules of oxygen, you will have to give 2 molecules of the whole compound, which will mean 2 molecules of magnesium also, 2 atoms of magnesium also. So when you write this 2 over here, it means that oxygen is balanced because there are 2 oxygens. But now magnesium is not balanced because there are 2 on this side and only 1 on this side. So what you do? You cannot make this half again. So you write a 2 over here, so that the number of magnesium atoms are also balanced. So it's 2 Mg plus O2 gives 2 MgO. Okay. So remember, when you're writing these numbers, you write it in front of the whole compound. So you just don't double the element which you want to double. The whole all the compound, all the elements present in that compound get doubled. Okay, so now let us try something harder. Fe plus H2O. This will give Fe3O4 plus H2. Now see, when you are balancing the equations, you will want to, in that equation only one was remaining unbalanced, but in this many are not balanced, like Fe, O, 2 are not balanced, only hydrogen is balanced. So in such cases, see where you can get the most complicated compound. You start balancing from that compound, because that compound will contain the maximum number of atoms. So here, if you see, the most complicated compound will be Fe3O4. So when you start balancing this Fe3O4, first start with Fe. So over here there are 3 Fe atoms. Over here there is 1. You can't make this 1/3 to make this 1, because fractional molecules are not allowed. So you make this 3. So 3 Fe, and here also Fe3. And this is just an element, so there are no other atoms to get tripled along with Fe. Now you see that here there are 4 oxygen atoms. Here there is 1. So what you do, in order to make this 4, you put a 4 in front of this. But this 4 multiplies with the oxygen, makes it 4 atoms of oxygen. So oxygen is balanced, but it makes this hydrogen, which was 2, it makes it 2 into 4, because 2, 2, 2, 2. So 2 into 4, there are now 8 atoms of hydrogen. And on this side, there are only 2 atoms. So what do? In order to make this 2 to 8, you must multiply it with a 4. So 4 into 2, 8. 4 into 2, 8. So hydrogen is also balanced. Iron was balanced. We balanced it at first. And oxygen is also balanced. So the whole equation is balanced. So the final equation will be 3Fe plus 4H2O gives Fe3O4 plus 4H2. So this is the final equation. And one more thing, after balancing the equation, to make it more informative, you can write down the state, the physical state of the each and every reactant and product. Like over here, it would be 3Fe. In brackets you write the state. Fe, iron is solid. So you write S in bracket. S stands for, okay, I'll give you, S stands for solid, L stands for liquid, G stands for gas, and AQ stands for aqueous. So here we have Fe solid plus H2O. In this reaction, remember that H2O is not in liquid form, it is in its gaseous form. That means you react it with steam. We'll give Fe3O4 iron oxide, which is again solid, and hydrogen gas, which is obviously gas. So to make this more informative, you can write down the states.